Hello, and thank you for joining the SaltStack Best of SaltConf 16 webinar series. This is Rhett Glauser. I'm with SaltStack. Today we have Drew Malone of Cloudera. He's a DevOps engineer with Cloudera. Thank you for joining us. There's a couple items of housekeeping and reminders before we get started and turn the time over to Drew. This is again, the Best of SaltConf 16 webinar series. We had about 70 talks at SaltConf 16, and we picked just a handful of the best for this webinar series. We've already heard from Krister Edwards of Adobe, Corey Quinn of Future Advisor. Those recordings of those webinars are available. Head to our blog, and you'll find more details there. Today, we're very happy to have Drew join us from Cloudera, and we'll talk a little bit more about what he'll be presenting here in a minute. If you're interested in the next webinar in the series, which is actually a presentation from, let's see. Sorry about that. We just had some background noise. I guess I'll jump right ahead and say I'm going to be muting all of the lines on this webinar just to preserve audio quality. If you do have questions, we do welcome them, but please enter them into the chat function within GoToMeeting, and we'll be sure to get to your questions. Like I mentioned previously, we are recording this session. We'll provide that recording to all registered attendees within about 24 hours of the end of this webinar. I was just about to say, if you're interested in the next webinar in the series, we will be hearing from Ron, who works for the U.S. Department of Agriculture, and he'll be talking about how he's using SaltStack to build essentially a microservices environment using Docker and SaltStack. Pretty impressive implementation with some substantial scale. So before I turn over to Drew, I just want to remind everybody that, normally these webinars are not an introduction to SaltStack. However, Drew is going to do a pretty good job at talking about all the things you can do, or that he has done or used SaltStack for. But if you are new to SaltStack and you're looking for some resources, we've got great documentation that's out there, and especially if you're just getting started, some really good tutorials on how to start using SaltStack for things not just for configuration management, which obviously Drew will be talking about today, but for things like remote execution, which is what Salt was initially built for, or maybe cloud orchestration, cloud control, or a unique capability of SaltStack that you're not going to find anywhere else. We call it event-driven orchestration, the ability for the machines to, in a way, manage themselves by responding to events and data that is machine generated. Or even if you are not interested, or your implementation is a little more lightweight, if you're looking for an implementation that doesn't use the traditional Salt Master and Salt Minion, the agent-based approach, we do have Salt SSH, which a lot of people don't know that we have. If you're looking for more of an agentless approach, and so information on all of that is available out on our docs. And if, of course, you have additional questions, just send us a note at sales@saltstack.com, and we can point you in the right direction, or we'd be happy to let you know what other resources we have available to help. So with that, I'd like to turn the time over to Drew Malone. Again, you've spoken at SaltConf 16 more than just this last year. I think at least the year before, and I believe you at least attended the previous SaltConf or spoke at that as well. So we just keep having you back for a reason, Drew. And so we appreciate your input and the content you provided. And of course, we want to make that available to folks that weren't available or able to attend SaltConf 16 this year. And so we welcome you to the webinar today. And I am giving you presentation rights now, Drew. And as soon as you get that, we'll send you on your way here.
Excellent. Thank you. Right. I appreciate the opportunity. A quick check. Is the screen share working correctly?
Looking good, and I can hear you just fine.
Excellent. Thanks again. Thank you, everyone, making it out here. Really appreciate you setting your time aside for this. We're going to get right into it then. As Rhett said, my name is Drew Malone. I'm with Cloudera, self-proclaimed DevOps guy. We're here mostly to talk about how a lot of people think about Salt in terms of configuration management, and the biggest point I want to get across here is configuration management is only one of the many capabilities that you have when you enter into the Salt ecosystem. So a little bit of background, partially reiterating what Rhett already mentioned. So I'm with Cloudera. If you were with the previous SaltConf back in 2015, you may or may not have seen my presentation on Salt the Cloud to make it rain. A nice little crash course into one of my favorite components, Salt Cloud. We'll get into that a little bit later in the presentation as well. And I was able to make it out for the very first SaltConf and was lucky enough to make it in as one of the first 10 engineers. All the Rackspace guys kind of pushed me out of the top 5. I blame them, but I'm happy with number 8. I'm happy. So to make sure that everybody is here for the right reason, everyone has their own expectations, reasons we're here today. So if you're brand new to Salt, you're in the right place. One of the most common, not complaints, but one of the most common comments and issues I hear from people who are new to Salt is there's so much to it. They don't know where to start. So we're going to simplify this and list out the components and show you good places to start and help you identify what components are going to help you solve your problems. If you've been around the block a couple times, if you're familiar with Salt, if you're a veteran with it, maybe you find yourself in a rut, maybe you've got some problems you're not quite sure how to tackle, we'll go over some of the components that you might not have heard of or might not have come across in your work, and we'll show you how you can apply them to the same problem. And I promise we're going to make this only as long as necessary. So we'll go over the interesting parts, and we'll be sure to have plenty of time for questions towards the end. A quick outline of what to expect. We'll go through a brief history course. What is configuration management? What exactly do we mean when we say that? We'll walk through the interesting components that Salt has to offer and give a quick description of what it is they do. Sort of a missing brochure type of presentation. Once we go through that, we'll then see what happens when you take those components and assemble them in interesting configurations to accomplish capabilities that you cannot get with any other platform, even the paid ones. The last bit is going to be a little bit of further reading for anyone who wants to dig any deeper into the community, into the various components. There's, like Red said, the documents on SaltStack are excellent, and it's very easy to get started and begin to get your hands around any of the components. So we'll go through a brief history course here. If everyone can go back in time a little bit, started out in your job, in your career. First day on the job, we have a lot of machines. They all need configurations. We're SSHing out to machines. We're updating configuration files. If you're really good, you can rsync them to a couple of machines at the same time. So the end result of this is everything is done manually. It's slow, it's not reproducible, and you get inconsistent results. So then you start to get a little bit better at what you're doing. You've got your configurations stored in one place. Your one command rsync one-liner has maybe turned into a shell script that you keep around in your home directory. So you take your 20-minute job and turn it into a 5-minute job that you can do on your lunch break. And since you now have a script that you use to get your work done, you're a little bit more consistent. And then finally, we learn what configuration management is. You take that script, you start writing more of them, you put them into a Git repo so you can share them with your team. So now everybody understands how to get something accomplished. You're now responsible for more services. You're able to deploy more services. You can deploy the services automatically. Your results are now consistent. Congratulations, everybody. You've won the game. Of course, everybody knows the reward for good work. Right, more good work. So just because we've accomplished what we came here for, all our services are running fine. Oh, well, you've gotten so good at this. Well, see, we need to upgrade this system, and we really have this other capability that we'd like to put together. And by the way, can this all happen dynamically? We have to merge these two completely unrelated systems. They don't know about each other. They don't have compatible APIs. You can make those fit together, right? Wonderful. Now we get to learn more technology, more tool sets, and I enjoy learning as much as anybody else, but I've only got so much time in my day. I can't be learning the entire ecosystem of tool sets. However, if you got to where you are by using Salt and all of the various components, it turns out you have a lot of capabilities in this toolbox that you may not be aware of. So this is the point that I want to make here. Salt can do a lot of things. So when you open up your Salt tool chest and you see something like this, you see a bunch of hand tools to try to get your job done, I'm here to tell you, in fact, what you really have is a collection of power tools that can get a lot more done, a lot more quickly, and a lot more seamlessly than you think that they can. So one thing I want to get out of the way real quick. Salt is not a configuration management tool. Salt is a parallel remote execution engine upon which you can build your configuration management capability. But you can do so many other things with this. This is the event-driven orchestration that Rhett was talking about earlier. We're going to get into this in just a moment. So we're going to go through the most common components. If you could recognize every single one of these components, congratulations, you have done your reading. This is, I'm not going to read them aloud to you. We're going to step through each of them individually, and we'll go ahead and do that right now. So the reactor is another one of my top 5 favorite components in Salt. This is where you can have real-time events correlate to actions by Salt. So this is where you can plug into your event bus that I had mentioned just a minute ago and make SaltStack execute some commands based on some event. And we'll have some real-world examples of this in just a minute. Salt Cloud is arguably my favorite component. This allows you to codify your footprint on any cloud provider. I've deployed and talked with other people that have deployed systems onto OpenStack, onto DigitalOcean, AWS, you name it. When you've codified your entire footprint in Salt Cloud, you create your capabilities in such a way that they're now portable. You're not tied into the cloud provider that you've chosen. There's no vendor lock-in. Salt API is what exposes your Salt installation to the rest of the world. Imagine, instead of having to log on to your Saltmaster to execute a command, if you can fire a curl request at your Saltmaster instead. And the implications for this are very large when you understand that you can build applications that send said requests out to the API. The Salt Mine is one of your components. This is what allows you to dynamically manage a lot of the boring configuration files. One of my favorite tricks is to manage Etsy hosts on all of your machines. So you don't have to worry about what IP address any of your minions have. You can have them report that IP into the Salt Mine, and then when you are managing your Etsy resolve hosts file, you can have that be a templated file that dynamically pulls all of the IPs and host names out of there. So you never have to touch your network config file again. So a state run will organize commands and services on a single host. Orchestrate is one layer up. So instead of a single run on a single machine, you are now coordinating multiple runs on multiple machines. A simple way to illustrate this is imagine a simple 3-tier web app that has to come up, and the database server needs to be built and turned on before your application farm comes alive. Orchestrate is what gives you the ability to define that order of operations. Salt SSH is one of those things that at first glance you say, that's kind of interesting. Don't have a particular use case for that. But when you come up against a customer or a boss or some sort of leadership that says, I'm tired of all these agents, we're not doing any more of those, this is where Salt SSH comes in. This is invaluable for your more stubborn customers that insist they're not dealing with any more agents. This makes it very easy to take your existing automation and just fire it at any existing machines. No need to install an agent or anything else. The Salt Vert is another one of the under-celebrated components of Salt, and you can basically turn your laptop into your own small private cloud. It's, if I understand, this was also partly where Salt began, was they wanted a system that had no database that could become a small cloud controller. So this works with any of your popular hypervisors, and it works very similar to Salt Cloud. You define your various profiles and map them to your operating system images, and with a single command, you can stand up a small test environment right inside your own laptop. Engines are processes that run on their own and next to your Salt master. So if having reactors, if having Salt API and everything is not enough for you, you can implement your own engine in full-featured Python. So you have the power of the entire Python language to accomplish what you want to do. So imagine a large data center. You have a large event bus that you're plugged into, so you have insight into all of your activity on your data center. This is your entry point for you to write code to respond to your data center. You can send log events to somewhere. You can respond and build new systems if you notice that some of your existing systems are overburdened. Really, the sky's the limit when it comes to engines. You're only limited by your own creativity here. Beacons are sort of an inverse relative of engines. A beacon is out on a minion, and this is your interface to reality. A beacon will monitor some external interface. The most common one is the iNotify beacon. So you can have a beacon that monitors a configuration file for you, and you don't have to wait for a scheduled Salt run. Your iNotify beacon will drop an event on the bus and will notify Salt that something has changed to your file that you care about. We're going to show this illustrated in one of our stories in just a little bit to make it a little more clear. And just in case all of these components are not enough, they can all be customized. You can write your own modules in Python. You can write your own grains. You can implement your own pillar. One of the absolute best things about Salt is it is intensely hackable. If you can write Python, you can solve any problem with Salt. So that's our whirlwind tour of the more popular components. So we're going to walk through a couple of use cases. Not all of them are mine, but I've spoken with people and gathered a few stories from other problems that people have solved. So let's see what happens when we put them together in more interesting ways. The very first one that comes to mind is going to be state enforcement. Everybody has a cowboy on their team. And even if you don't have a cowboy on your team, it's still nice to have a mechanism to avoid even accidentally messing something up. So what happens when we take the iNotify beacon that I had mentioned and plug it into reactors? If we have a list of users that need access to some system, we can manage that list of users in Salt. Very simple. We use a Salt master, we push all those configs out to our systems, everything is under control. Excellent. However, that is still just a text file on a machine. And there's not always something preventing a rogue user from getting access to that text file and adding his buddy to the system. Yeah, sure, I can get you access to that. Let me just put you on this list real quick. Right, that's how Friday night outages happen. We don't want that. So our iNotify beacon is going to send something back to the Salt master and say, this file you care about, this thing's been modified. You need to put it back to where it needs to be. So an event is dropped on the message bus. We've configured Reactor to react to this event by rerunning the exact same Salt states that are responsible for managing the file. So there's not a lot of extra work here. We're just rerunning something that we have already written. That reactor is going to fire, it's going to rerun the Salt state, and it's going to remove those rogue modifications and put the system back into a state that we need it to be. Salt Cloud, again, one of my favorite components. Codify your environment. You find yourself teaching technical classes, one of the most important things is providing an environment for your users. Sure would be nice if you could just carry around a configuration file and fire that at the cheapest cloud provider of choice. You can run a class in Rackspace on one week, you can run it over on DigitalOcean in the next, and all you have to do to deploy it is just plug it into Salt Cloud and fire it off. You can scale your number of machines up or down as needed, however many students you've got. It makes it very easy to capture what an environment looks like when you need to deploy it. You can also use this when you're deploying these applications. Salt has very fine-grained tuning to use with this. For example, for an AWS implementation, you can deploy machines across specific availability zones. So when HA is important to you, you can evenly distribute the machines that you need in the appropriate areas that you want. It won't just blindly fire them in. You can be very specific and attaching volumes and being whatever level of granularity you need when you deploy these machines. So another use case is a classical web app environment. So on the left-hand side, we've got a YAML file that describes an application server, our MongoDB backend, remember it's just a toy, and a reverse proxy that we're going to implement with Nginx. And this is what we call a map file. This represents our deployment. This is a very simple and contrived one, but this will deploy 3 machines for us, and it will roll out our applications. It'll connect them to our Salt master for us, and then from there, we run our salt states. We have an application up and live on the internet. So like I had mentioned previously, the power in Salt Cloud is portability. Why does portability matter? Because pricing changes. When you query through Salt Cloud, it will make a best effort to get any pricing details from that cloud provider. Not all cloud providers give this, so it won't always work. But if the cloud provider does give pricing through their API, Salt Cloud will find it. So this allows you to plug something into a streamlined capability where you can have an automated task if you need to burst out and run some highly compute-intensive process, and you don't care what provider it's on because you don't need any cloud-specific tools. You can use this. You can calculate what the price would be to run your deployment out on your cloud provider, find the cheapest guys, roll with that, deploy it, get your work done, and tear it down, saving money. So again, with the Salt Cloud sort of approach, taking Salt Cloud and tying it in with Reactor gives us your own auto-scaling that you can control. So our classic use case is we have a website. It does a thing, and it found a user. Rather, a user found it. We've got a success. User tells all of his friends, and they tell all of their friends, and before you know it, your site is getting the internet hug of death. How do you survive this? You need more resources at this. You don't want to sit here and monitor your resource consumption and manually deploy more servers into your app farm to adjust for this. This is why we have Salt managing our deployment. Again, back to this event-driven orchestration. On your event bus, your minions will be reporting on this event bus, we're overwhelmed, we need help. You have a reactor that's looking out for that. Your reactor can run your Salt Cloud commands to add more servers into your app farm. So you increase your horsepower, you survive the internet hug of death, and now you get to appreciate and enjoy your popularity instead of becoming a victim of it. All with no intervention, no hands manual adjustment. So it's a lot of work, I'm not going to lie. This takes understanding Salt Cloud, it takes understanding Reactor. Why not just go with AWS and use autoscaling? Which, that's fine, but the problem with going that route is you will always use AWS and autoscaling. You cannot take it on premises for a customer, you cannot take it to a new cloud provider, you're stuck in AWS. So this is the power of sticking with open source solutions and of sticking with Salt. When you build your own capabilities, you avoid vendor lock-in, you avoid proprietary solutions, you go where you need to go, not where the golden handcuffs keep you. So I told everyone that I would give a quick story on Salt API. This is great for continuous integration. I love being able to show my team, look, we manage all of our configurations in Git. When you want to see your configs live in Git, all you have to do is just push them out there. They get rolled out to production. You don't have to do anything. Here's how we do it. So we have our monitoring system, Remon. It's a pretty good open source monitoring solution if you're in the market. Worth a look. So the configs are stored in GitHub, and everything is managed with Salt. So I tell my developers, you have a new Remon config, you want to get it out in production, just commit and push to the master branch, and wait just a couple of minutes, it'll be in production. We have our hook in our Git repo that sends an HTTP post over to our Salt API that lives on our Salt master. This API causes an event on that event bus. Remember, event-driven orchestration. Our reactor is looking for an event that correlates to this HTTP post. What do we do when we get that post? We make sure that our Remon configs are up to date. That's what we do. So we've taken the entire flow of a developer pushing into Git, causing that to update some salt states on the master, which then jump out to the Remon machine, get the latest configs, restart our Remon service, and our new configs are now in production. And of course, Remon is just a small, simple example here. You can, of course, scale this up to whatever service you need, whatever applications, wherever it is that you can write your automation to deliver it, you can make it happen in your ecosystem. So the last story I want to go over here is another combination with Salt API and Reactor. Not quite continuous integration, but still automating a lot of hand-driven tasks. So Hadoop is hard. So is Kerberos. So what about when you need to combine Hadoop and Kerberos? A lot of organizations need to run secure big data clusters. A large part of what Cloudera as a company offers is support. We help our customers succeed with their Hadoop clusters. How do we do that? We build Hadoop clusters on our end to reproduce problems that they're having. So we need to build Hadoop clusters quickly. Sometimes they need to be Kerberized. How do we do that? If anyone out here is familiar with how involved it is to set up identity management and plug it into a Kerberized cluster, you understand that there's a lot of moving parts here. So here's how we did it. We have a quick list of what we used on here. We have a Windows machine that's running a small Active Directory instance. This is not tied to corporate. It is a single standalone used specifically for this use case. We're using Salt API to receive the requests for every time that someone needs a Kerberized cluster, and we're using Reactor in exactly the same way that we have in the previous ones. And then we're taking a PowerShell script that we've templated with Jinja to dynamically configure some things on the back end in Active Directory. So illustrated, this graph looked a lot better when I made it months ago. So our use case is we, Cloudera, have an internal tool that we use that allows our engineers to deploy these Hadoop clusters on demand. So on this web form that they fill out for a Hadoop cluster, they can check a box that says, by the way, I need this Kerberized, please do that for me. The engineer needs to do nothing else. Everything else is automated after that. When they check that box, our deploy application sends that HTTP post over to Salt API, which says, hey, somebody has requested a Kerberos Hadoop cluster. I need you to make some configuration changes in Active Directory. I need you to make a new OU. I need a new service account created. I need delegation given to that service account. A lot of Windowsy things that are very difficult to automate, but it is possible. So the end result is we don't have to have all of our engineers logging into our Windows system, manually creating their OUs, manually creating their service accounts. I don't even want to think about a reality where we have to manage user accounts for our engineers who are manually creating something in an identity management system. By automating all of this, we have kept all of the user accounts out. No one has to log into anything. Everything is built just as we need, and it's been highly successful. So in the spirit of keeping things only as long as they need to be, we can't go over every single component that Salt has to offer. but there are some that are absolutely worth your time, worth looking into. At a glance, Salt Syndic is a master of masters. So for geographically diverse salt deployments, you can have a salt deployment that is literally around the planet, and you can manage them using Salt Syndic. You can command and control it from a single point. Returners are another undervalued component, especially if you need an audit trail or if you need a better way to track and to confirm that your salt runs were successful. Returners are for you. You can take all of your salt jobs and put them into a database of your choice for further exploration and interrogation later on after the fact. SDB is, again, the capability to store more interesting information relevant to your deployments on the salt minions. Again, back to the customization of your deployments. And something that not everyone realizes is there's a lot of authentication layers happening in a typical salt deployment. And you are not stuck just with the default ones. You can plug, again, into any sort of external authentication system necessary. And this becomes useful, again, when you start building complex capabilities on top of Salt, and you find that the default auth module isn't working for you. It's very pluggable to get what you need. So to get back to the point, Salt is so much more than configuration management. Salt is a platform where you can build real-time capabilities and you can build your event-driven orchestration on top of this message bus. This message bus is the central nervous system into your data center. It is your insight into your activity, and it's your hook to take action when you see that things have gone astray or if something needs to change without you having to interfere manually. And before I hand it over to Q&A, I want to just repeat what Rhett had said earlier when we started here. The documentation on the SaltStack website is amazing. It's very verbose, and if for whatever reason you find that it's not meeting your needs, it's very easy. I've done it myself several times. I've seen people do it very quickly. It's very easy to file a pull request against the documentation if you feel that you need to fill in some of the gaps. Everybody always appreciates it. And it's absolutely worth your time walking through some of the tutorials to get yourself spun up real quickly. And if the documentation isn't working out for you, the SaltStack channel on IRC, the community is very nice, especially for such an aggressive open source product. Everyone there wants you to succeed, and it shows when you start talking. They're very helpful and very nice, and I can't speak enough good words about the IRC channel. So with that, I'll go ahead and open it to the floor or give it back to Rhett if there are any questions from the audience.
Yeah, thanks, Drew. We have had a couple questions come through, and we'll get to those in 1 second. Just as a reminder, I know a few people showed up a little bit late for the webinar. We have recorded it, and we'll get that recording to everybody. If you do have any questions, make sure to enter them into the chat function and GoToMeeting, and we'll get to those. And just to follow on to what Drew was saying, if you're interested in all the various resources, community resources that we have for the Salt open source project, if you go to saltstack.com/community, you can find where, for example, you can find where the IRC channel is. You can find the mailing list. You can find, our YouTube channel. You can find the dozens and dozens of user groups that we have around the world for meetups. If you're interested in meeting like-minded folks in your area. So yeah, check out that webpage, saltstack.com/community. Lots of resources are there, and of course, if IRC isn't enough, or if you need paid support offerings or professional services, of course, SaltStack offers that as well. Just send us a note at sales@saltstack.com. But like Drew was saying, we really want people to just get up and running and successful with all the power and capabilities of Salt Open as quickly as possible. And so a good place to start is the docs. And okay, so let's get to a couple questions. We did have, and I think this is kind of a multi-part question, Drew, and I'll lob it out there and see if this is something you can address. Maybe we'll have to take it offline. But the question is about how do you track errors in multi-step workflows where you get partial success and partial failures within the workflow? And then I think that the second part of that question is how to get that workflow back to a no good state. I believe, as opposed to a minion or a system back to a no good state, I think is as how the question is being asked there.
Sure. So my understanding is we want to deploy some system, and halfway through the deploy it fails, and we need to know why. Do I understand that properly?
I believe so. That looks yeah, that looks to be accurate.
Sure. It's so there's a few options, and it also hinges on what exactly do you need done. Obviously, you need it to succeed, yes, but there are some capabilities when writing salt states. You can have I'm aware of a fail hard option when writing salt states, so that if some critical portion of your run fails, the entire run will just shut down. If you're trying to track what happened, and what's coming back on your screen is insufficient, two places come to mind immediately. One is for a sufficiently large deployment, you may want to consider returners. If you have something, say, if it's more than just a single minion, if you've got dozens of minions and just tracking something on a screen or a log file is never going to work, you can easily set up a returner to dump into whatever is your most convenient database, and that gives you a lot more visibility into exactly what actions are going there. A less extreme example of returners, honestly, as lame as it sounds, could just be the log files. If you have the ability, one of my favorite techniques is to jump out to a minion, and instead of the classical salt command that you issue from the master, there's going to be a salt call command to initiate a run from the minion. And your runs have all different levels of debug options. So I believe there's a -L flag for your salt call command. And my go-to is going to be -L debug, and it makes it very chatty. I use it when I'm trying to impress some people with how much is happening under the hood. If you really hate yourself, you can set that to trace instead of debug, and you'll get a lot of information out of there. And that's with running it just, again, on the screen, which understandably is not always helpful. So there's always the option of just setting the config option in the daemon itself and examining the log file afterwards. And that's the best of my knowledge there as far as troubleshooting.
Okay. All right. So I would say to the person who to ask that question, if you do have additional questions along those lines, please just send us a note and we can get you some additional detail. And a bit of a shameless plug here, I guess. We have customers and users who are managing thousands and tens of thousands of systems and nodes using Salt. And like Drew was saying, all that data, all that chatter can become overwhelming, especially if you're trying to consume it all through, a command line, for example. So Salt, all the things that Drew talked about today are available in the open source Salt open source project. However, we do have an enterprise version of the API that drives a graphical user interface and allows us and our users to consume that massive amount of information that can be created in a often typical large SaltStack implementation. And so there's something else to keep in mind there. I guess, so again, if you do have any questions, please enter them into the chat window. One other question for you, Drew. Tell us a little bit about your background in terms of, it sounds like at the beginning of the webinar, you shared a little bit of, what configuration management looked like before tools like Salt. But have you had any experience with any of the other maybe competitive tools to Salt, either within config or for configuration management or for just systems management generally? And maybe you can share a little bit about why Salt I guess is kind of your tool of choice.
Absolutely. I almost have a canned speech at this point. Very good question. Valid. Absolutely good question. When I first started learning Salt, I was with a different company, a different customer. Basically, we had to field this question all the time. It was, why Salt? And often it was followed up with, why not use Puppet? For reasons that are typically obvious when you're working in a large enterprise and there kind of develops a de facto solution to all problems. And I say this without judgment. At the time, that solution was Puppet. So not only were we trying to introduce a new technology, a new capability, we also had to defend ourselves quite often. So in short, yes, I've played with Puppet some, not as much as some of the others. I've also done. I basically ran my own personal bake-off about 3.5 years ago. Puppet is again, without judgment, it's just so opaque. Puppet was the first technology to enter into configuration management to make it as big as it is. I'm not going to say they're the very first, but they're certainly among the first, and among them first that were successful. They were the first, and it shows. They, from a technology standpoint, they carry a lot of baggage that makes your solutions brittle, and they're not as flexible as what you can do with Salt. Especially a lot of the more dynamic capabilities, deploying something into a cloud provider of choice. I haven't seen anything like the reactor capability as an example. I'm not sure how you would get your seamless continuous integration with something like that. I don't want to dig on Puppet. It's not their fault. There's nothing wrong with it. This is just my experience in going through it. There was also, when I tested out Chef, if all you're after is configuration management, Chef could work for you. Chef is an absolutely solid product, and I actually started to appreciate what seems to me to be an opinionated way that they built it. They sort of force you to organize all of your recipes into a Git repo or into somewhere organized. There's no such thing as a one-off in Chef, from what I can tell. I could be wrong, but in my experience, there's no such thing as ad hoc commands or queries or anything like that. And while it gives you some sanity and some stability, it's also, it just proves my point of why I love using Salt. There is such a thing as ad hoc commands in Salt deployment. As an example, we run an OpenStack cluster in our data center. We need to know just at a glance. We don't have any dashboards. We have no really evolved systems to see health and statistics aside from our own remon monitoring. So just at a glance, how much memory is free on all of these machines? It's very easy to just issue the Linux free command to get back what's the status of the memory on this one machine. But when you've got 25 machines, even a parallel SSH becomes a little bit cumbersome. With a Salt command, a Salt deployment, all I need is a command.run, and I get to fire my free Linux command off to all of my machines, and on my screen with the, of course, it's only 25 machines, it's not much. I can see all of their output, and at a glance, in under 10 seconds, I can get a feel for what the status of my machines is. This is also to something that older issues like Heartbleed and other interesting 0 days. 0 days are rendered a moot point when you've got a Salt system. You don't have to package anything. If all you need to do is just grab updated packages from your already configured repositories, all you need is a single update command, and you can run all of those commands in parallel on your entire system. And there's no real waiting. As long as it takes for a single machine to do it, that's as long.
Drew, are you still there? I'm wondering if I'm the only one who lost you, or if we lost the connection to you. Well,
I lost him too.
Okay, thank you for confirming. Well, I guess we were at about the end of our webinar there, so apologies for the cutoff, the abrupt cutoff. But we'll end it there, and appreciate everybody joining us for the webinar. Glad that happened towards the end as opposed to the beginning. But like I said, we are recording this. We'll make sure the recording is sent to everybody who's registered, and thank you for joining us today. We will be in touch briefly. Thank you. Bye-bye.